Hey guys, in this video we're looking at quadratic equations. Now this is an interesting part because I guess often I teach the null factor law before this. The null factor law is going to be coming in the next video. So I would even encourage you to watch both at the same time. Hopefully they complement each other. Okay, so equations. We all know that any expression that has an equal sign becomes an equation. In this case, we have a quadratic equation, which is just an expression that has a term that includes a squared pronumeral. Okay, so like an x squared. So anything that says x squared, let's say 5x squared minus 2x plus 3, that is a quadratic expression because we have an x squared term. The moment that there is not an x squared term, it becomes a linear equation, a straight line graph. Okay, so in this case, 5x squared, we're going to have 2x squared plus 4x minus 12 on the right hand side. So basically whatever's on the left is equal to whatever's on the right. Okay, doesn't matter how long or how big or complicated they look. Simply an equation says the left equals the right. For this particular purpose here, I just want you to, I guess, revise your balancing of equations. And we're going to put everything basically on the left-hand side. So everything here on the left. And obviously, the moment that we get rid of everything on the right-hand side, that equates to 0. Okay, so I'll show you what we're doing here. I shouldn't have erased all of that. Here we go, that's better. All right. So let's get rid of the 2x squared by subtracting 2x squared. And so 5x squared minus 2x squared is 3x squared. We're going to then also get rid of the 4x by subtracting 4x from both sides. So minus 2x squared minus 4x is going to be minus 6x. And then we're going to add 4, okay, because this is a negative 12. So we're going to add 12 to counteract that. So 3 plus 12 becomes 15. Okay, so then we've got this equation where we have 3x squared minus 6x plus 15 equals 0. The coefficient of x squared is your a term. Your coefficient of x is negative 6. That's your term of b. And your constant is c. Okay, there is no x term next to it. So remember, our quadratic expression or format is ax squared plus bx plus c. And if you were to derive certain values, that is where you'll need to draw it from. Okay. So now it comes down to, well, we get to this point and we want to solve and work out what x these values are. Okay. And so we'll start off with something simple. And let's say we have 2x squared minus 18 equals 0. We want to solve for x, okay? Just like any linear equation, we want to know what x equals. And in this case, we've got a negative 18, and we can move that across to the right-hand side by adding 18. That's the first thing that we need to do to get rid of, to isolate x on its own. So remember, when we want to strip things apart, we use SAMDOB. Okay, so SAMDOB, we want to use attack the subtraction or addition first before we move on to the multiplication division. So 2x squared is equal to 18. Next thing is we can get rid of the 2, and it's multiplied by multiplied to the x. So we need to divide both sides by 2. Can't only do it on one side, you need to do it to both to keep things balanced. So we've got x squared is equal to 9. The last thing is, to get x on its own, we are needing to square root both sides. Now, to square root both sides, you would think, well, the solution is 3. Correct. But when we're dealing with quadratics, and this is where things get a little bit more complicated, is that there are actually two solutions. There is a positive 3 and there is a negative 3. So if you were to substitute negative 3 into x squared, two negatives makes a positive. So positive 3 squared will give you a 9. Negative 3 squared is also going to give you 9. Okay, so we're going to do a few of these and you'll see what I mean by this. Okay, so I want you to understand that there is two solutions here. What happens if we have, say, something like x squared plus 9 is equal to 0? It looks a lot easier than the others, so we would want to move the 9 to the right by subtracting. So we end up getting x squared equals negative 9. Obviously, what you want to do is to square root both sides. And the problem here is that you can't square root a negative number. That is not possible. You can only square root a positive number. Okay, and so because you can't square root a negative number, so I'm going to put a red cross on both of this. The answer is there are no solutions. Okay, there's no answers to this. It's not possible. We're going to move on to something a little bit more complicated, and we'll just build up from here. And if you have any questions, please let me know. Otherwise, you can always rewatch these videos and hopefully it will start to click in and make some sense. Okay, so if we have 3x squared plus 4 is equal to 4, then you would think, okay, Sam Dobb, same thing. You want to start off with subtraction and addition. Let's get rid of the 4 by subtracting 4 from both sides. So 3x squared is equal to 4 minus 4 is 0. And you go, oh, what's going on here? There's nothing on the right-hand side. That's okay. The next thing is that you'd want to divide both sides by 3. Okay. And you have x squared. Well, anything that you're going to divide 0 by is just going to be 0. You can't divide nothing. So it's just going to be 0. And then if you're going to square root both sides, the same thing. It's all going to be 0. So something as simple as this will give you a simple answer. Don't want you to be confused by it or thinking that, oh, what's going on here? Why is it like this? Again, if you are methodical, if you are taking it slow, if you are rewriting every single step and you're making sure that each step is correct, don't be phased. You're going in the right direction, and you can always backtrack and see where things lead if you go back to the start. Okay, next one. We're going to have 3 outside of x plus 2 all squared is equal to 27. And as I've shared earlier on in the chapter, if you want to get inside the box, you want to start outside the box, the 3 is going to be your starting point. And so we're going to divide both sides by 3. And we have x plus 2 all squared is equal to 9. And because both, you could say that the 9 is the same as 3 squared, is a squared number, okay? And therefore, we can actually square root both sides, and we'll have just x plus 2 on the left is equal to 3. Now remember, with the other question, we had x squared is equal to 9, x is equal to 3, and negative 3, okay, both values. We're going to have the same thing here. So we have x plus 2 is equal to positive and negative 3. So we have x plus 2 is equal to positive and negative 3. So we have, again, two solutions. So we can have, to get rid of the positive 2, we're going to take 2 from both sides, okay? But because we have two numbers, we have a -3, +3, and a -3, we're going to be taking 2 away from both of those options. So x is going to equal, what's 3 minus 2? It's just 1. And -3 minus 2 is -5. So our two solutions for x is 1 and -5. If you ever want to know if you got it right or not, you can substitute it back into the original equation. And so, for example, here we took out 1. 1 plus 2 is 3. 3 squared is 9. 9 times 3 is 27. So that is true. That is a possible solution. Let's try -5. -5 plus 2 is -3. -3 squared is 9, and 9 times 3 is 27. So both can actually work and get you to the same answer. So there are two solutions for x. And so this is going to lead me into helping you check if the solutions that you have are actual solutions for these quadratic expressions. So let's say we have x squared is equal to 4x minus 3, and you were given x equals 1, x equals 2, and then x equals 3. And you want to know, well, are any of them true? Well, simply you just substitute in for x. Okay, so we'll have 1 squared is equal to 4 times 1 minus 3, and 1 squared is just 1. 4 times 1 is just 4 minus 3. 4 minus 3 is just 1. So 1 does equal to 1. Both sides are the same. So we could say that yes, it is a solution. Okay. Now, if we were to substitute 2, so we've got 2 squared is equal to 4 times 2 minus 3. 4 times 2 is 8, minus 3 is 5. And 2 squared is just 4. Okay, well, 4 does not equal 5. Therefore, that, let me get that back, that is not a solution, because when you substitute it into it, both sides do not equal the same value. Let's try x equals 3. So we've got 3 squared. 3 squared equals 4 times 3 minus 3. Okay, so then 4 times 3 is 12, minus 3 is 9. And 3 squared is 9. So 9 does equal 9. We could say that 3 is also a solution. So we're looking at this expression. It is both, we have two solutions for x. X can equal 1 and x equals 3. So they are things that you can do. Once you've factorized, once you've worked out some solutions for the quadratic expression, you can resubstitute into the original equation to just verify your working out. Okay, well, hopefully that segment has helped you with this part. I'll see you in the next video.